Yes, we are live. Welcome to Math with Doug, Fractions with Doug. This is the last session about fractions before we move on to something else. That's cool. Okay, what's going on? It's still October, it's still cold out, I'm still wearing slippers, so not much has changed in the past few weeks. This is a Liverpool jersey. Yes, Liverpool. Beautiful jersey. One of my favorites. It shows the chalk dust really well though. Mocha is upstairs. She is not available for today's lesson. She's busy. I think she was reading a book. Anyway, what we are going to cover isn't really so new because we're doing a lot of addition, subtraction, multiplication, and division of fractions. The only thing that's new is before, when we did these operations on fractions, we were mostly dealing with proper fractions. We did not have improper fractions. We did not really have mixed numbers. So what happens with fractions though is that you encounter improper fractions and you encounter mixed numbers quite often, and you have to be able to handle it when you need to do operations like the four basic operations: addition, subtraction, multiplication, division, with those. So what do? Sometimes there are choices, and people, when they have choices, can choose their favorite way, but it's nice to know all of the different ways to approach a problem. So right away, I'm going to get into a fairly basic example. I'm going to write 4 1/3, and I am going to add to that 1 1/3. Now, this is a fairly straightforward one because we are adding fractions, and when we add fractions, we think about the denominators, and we realize, oh, well, in this question, we already have a common denominator. But of course, it is the introductory question. I don't want to get into the more challenging questions right away. I want to start with something that's not too crazy, too scary. And I'll even go back to the beginning, and I'll draw some pizzas to show this. 4 1/3 plus 1 1/3. Well, that could be 4 1/3 pizzas plus 1 1/3 pizzas. So I'll draw those really quick. I need 4 whole pizzas. So I'll draw them. We won't worry about what size these pizzas are. They're all the same size. And I need 4 pizzas to show this 4, but I also have that third of a pizza. So I'm going to have to draw another one. And then to add the 1 1/3, well, I don't really have much room way over there, so I'll just draw them down here. We have 1 pizza, plus we need another one to show the third. Now, since they're divided into 3 pieces, I better get busy doing that. So I'm going to do all of these pizzas divided roughly into 3 equal pieces. This does take a while. Maybe I should have started with a smaller number than 4 1/3 pizzas. But we can get there. Okay, so all these pizzas have been sliced up. Now this set, the 1 1/3 pizzas from over here, also has to be sliced up. And of course, you use your favorite shape. It doesn't have to be a circle. You can use any type of shape that you want when you want to draw fractions out like this. 4 1/3 means we have 4 complete pizzas and a third. So there's 1 piece left in here. And then the 1 1/3, we have a complete pizza and a third. And now we can add together and we can see how many pieces we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Well, we have 17 slices of pizza. But how do I do with the numbers? And do I want to say how many slices I have? I want to give my answer in the form of a fraction. Does that mean I have 17 thirds? Well, I guess we'll find out. What we can do is we can separately add the whole number part of the mixed number. 4 plus 1 equals 5. And then we add the fraction parts. So 1/3 plus 1/3, because it's already over a common denominator, 1/3 plus 1/3 is 2/3. And of course, if I wanted to convert this mixed number into an improper fraction, what would I get? Big number times bottom plus top. 5 times 3 is 15 plus 2 equals 17. Hey, it is 17 thirds. So it makes sense. When you draw it out with pizza slices or with chocolate bar slices or dividing squares into pieces, that sort of thing, it gives you the same answer, and it gives you the right answer, but we want to be able to do it with the numbers, and this is how we do it with the numbers. I'm not going to be drawing any more pizzas today. All right, let's move on to a second example. Lots of erasing, lots of chalk dust from that illustration. How about, here's another one. Keep an eye on the time. Of course, I am still very much at the beginning. How about 3 1/2? 3 1/2? No, it's not 3 1/2. 3 1/5 plus 2 2/5. So again, this is a fairly simple one because we already have a common denominator, which means we can get right into it. We can add the whole numbers. 3 plus 2 equals 5. But then we can also add our fractions. 1/5 plus 2/5 equals 3/5. So it really is as easy as that. It is a way of adding two mixed numbers. Do we have to do it that way? No. What we could do if we really wanted to is we could convert this into an improper fraction. We could convert that into an improper fraction, and then we could add them in a way that we're more used to. They would be improper fractions though. The numerators will be bigger than the denominators, but that's okay, it still works. So converting 3 times 5 is equal to 15 plus 1, that is 16/5. Now I know this is a review how to convert an improper fraction, a mixed number into an improper fraction, which is why I'm going so quickly. Now let's do this one. 2 times 5 equals 10 plus 2 equals 12/5. Denominator stays the same. At this point, I can add these because they have a common denominator. When you add, the denominator stays the same. 16 plus 12 is equal to 28. We end up with an answer which is an improper fraction. If we want to convert it into a mixed number, because that's what we started with, let's convert it into a mixed number, we're doing the same technique that we've been practicing. 5 fits into 28 5 times, so the big number is 5. The denominator will be the same. When I do 5 times 5 to get 28, I have to do a subtraction. 28 minus 25. So 5 times 5 gives 25. I have to do a subtraction. 28 minus 25 is 3. My remainder is 3. It's the same answer. So really, you have a choice which way you want to do this problem, unless you're doing an exercise where you're being asked to practice this method or practice that method. But both of them work, and that's the thing that's important. When we know two different methods to do the same thing, and we know they both work, well, then we have a choice. And we also can use one of them as a way of verifying the other, which is another thing I really like to do in math. Okay, so I'm not going to do this method very much. I'm practicing this method for now. I find it very useful for addition and subtraction of fractions when we have mixed numbers. Let's move on to my third example. Okay, 2 3/10 plus 2 1/5. Okay, now we don't have a common denominator. We were kind of lucky to have common denominators right from the start with the previous two examples, but they were the first two examples of the lesson. You don't always get lucky and have a common denominator. You have to be able to convert your fractions so that they're over a common denominator when you are adding fractions. We already knew this, but when we have mixed numbers, well, we have to do the same thing. So what I need to do is figure out what's the lowest common denominator of this 10 and that 5. And it's the same technique that you use when you are adding regular fractions that are not mixed numbers. The lowest common multiple of 10 and 5 is 10. So therefore, I don't have to change this first fraction. It's already over a 10. It's already over my common denominator. But this one, notice how the 2 isn't changing. The big whole number isn't changing. But if I want this fraction to be over a 10, well, 5 times 2 is equal to 10. So I have to do 1 times 2 equals 2. I am expanding the 1/5 to be a 2/10 so that I have my common denominator. And now I can go ahead and answer the question. 2 plus 2 equals 4. 3/10 plus 2/10 is equal to 5/10, and there's only one thing left to do. This time I ended up with an answer where the fraction part can be reduced, so I may as well reduce it. How do I reduce 5/10? It's a bit of an easy one. The greatest common factor between 5 and 10 is 5. I'm dividing both of them by 5. So the 4 doesn't change. 5 divided by 5 is 1. 10 divided by 5 is 2. 4 5/10, of course, is equal to 4 1/2. I have my answer. It's in the form of a mixed number like I started with, and it's simplified as much as I can. And that's just another example. But when we don't start with a common denominator, does it cause a problem? No, we can still do it. Let's do another one. My next one already has a common denominator. Is that what I want? I guess I'll do it. Okay. So we already learned how to deal with it when the denominator is not already common, but we end up with another question where the denominator is common. 7 and 1/12 plus 3 and 5/12. Okay, I can just go right ahead and do it because the denominator is common. 7 plus 3 is equal to 10. And 1/12 plus 5/12 is 6/12. Aha, I have my answer. It is the correct answer, but I can reduce this. 6/12. The 6 and the 12 have a common factor of 6, so I can divide top and bottom by 6. The big number stays the same. 6/12 reduces to 1/2. I have divided the 6 and the 12 by this, well, I've divided the fraction part by the clever form of 1, which is 6 over 6. I can show that part if I want. But it is a review, so I am able to go in a little bit more quickly. Okay, so that's fun. Let's do another one where the denominators are not already common. Okay, how about... 4 and 5/8 plus 1 and 3/4. Okay, what's going to happen with this one? We don't have a common denominator. We have to make sure we have one. The lowest common denominator for this 8 and this 4 is going to be 8. The lowest common multiple of 8 and 4 is 8. So I'm going to convert this. The 4 will stay the same. This is already over 8, so the first fraction will stay the same. 4 and 5/8 doesn't change. The second one, the 1 stays the same, but the 3/4 has to be expanded, so it's over an 8. So I am doubling both the top and the bottom. 4 times 2 is equal to 8. 3 times 2 is equal to 6. I have 6/8. Now I can continue on, and I think I'll move it over here. The whole numbers, 4 plus 1 gives me 5. I'll put an equal sign. And then 5/8 plus 6/8 is giving me 11/8. Okay, well, something interesting happened. Now, this has happened before. It just looks a little different now. Because we have the whole number part, we have the big 5 part. But sometimes when you add fractions, you end up with an improper fraction as your answer because the numerators add up to equal a total that is larger than the denominator. But how do I deal with this? The way I'll deal with it is I'll say, I have 5, and 11/8, I can convert the 11/8 part, which is a little improper fraction of its own, into a mixed number. So how do I convert 11/8 into a mixed number? I say, how many times does 8 fit into 11? Just once. That's my big number. 8 times 1 is equal to 8. I do a little subtraction. 11 minus 8 is equal to 3. That's my remainder, and it gives me my numerator. And the denominator stays the same. So 5 and 11/8 is equal to 5 plus 1 and 3/8. Notice how I slow down. When I'm doing something that could be a little confusing, where I could make a mistake, I slow down. Yes, does this make sense? 5 and 11/8 is equal to 5 plus 1 and 3/8, because 11/8 is equal to 1 and 3/8. So I can do this little operation off to the side if I need to, so that I can keep it straight. And then 5 plus 1 and 3/8 is going to be 6 and 3/8. And we have our answer. And the answer is simplified. The numerator is not greater than the denominator. It was an extra step to do, but it wasn't a difficult step because it's a step that we have been practicing for a couple of weeks now. Okay, that was an interesting one. How about a subtraction? Let's do a subtraction. And because we are moving on to subtraction, I'm going to go back to using fractions that already have a common denominator, at least for this first example. Yeah, it's just for the first example. 3 and 4/5 minus 2 and 1/5. it works just like the addition. Now that we can add two mixed numbers, we subtract two mixed numbers in the same way. We subtract just the big numbers, the whole number part, to start with. 3 minus 2 is equal to 1. 4/5 minus 1/5 is what we do next. We're just subtracting the fraction parts. And because they're over a common denominator already, I can just go ahead and do it. The answer will have 5 as a denominator. 4 minus 1 is equal to 3. I have 1 3/5. That's my answer. So it's no different than addition. Again, let's do this one the other way if we want, just to see a sort of a verification. I can convert this 3 4/5 into an improper fraction. 3 times 5 is equal to 15 plus 4 is 19. That is 19/5. I'll do the same thing here. 2 times 5 is 10 plus 1 is 11/5. 19 minus 11 is equal to 8/5. That works just like usual. But then, this is an improper fraction. I'd like to convert it into a mixed number because that's what I started with, but it's a pretty fast one to do. 5 fits into 8 one time with 3 as the remainder. 8 minus 5 is 3, and the denominator remains the same. We're not surprised to see the same answer here that we had there. That's why we're doing this. We're proving to ourselves that this method works because it gives the right answer, and this method also works. It also gives the right answer. It's good to know two different ways to do the same thing. Take a quick look at the time. I'm doing very well for time. Here's another one. Now we'll do a subtraction where we don't start off with a common denominator. And before I get into writing that one down, I am going to take a quick sip of my fizzy water because I am starting to have a dry mouth from all this talking. And this is root beer flavored fizzy water. Yes, there is a slight hint of root beer in there, but it is a 0-calorie drink, which is what I need, and it is refreshing. Okay, the next one is 2 2/3 minus 1 1/6. So I can go into this and I can rush into it and say 2 minus 1 equals 1. And I think that I'm doing okay when I do that. I think that I'm not in trouble to do that. But no, wait. I don't have a common denominator yet. I don't want to rush this too much. So what I'm going to do is I'm going to convert these so they're both over the same denominator first. Now when that happens, these numbers can change. Do these numbers change? No. No, they don't. What is going to be the common denominator when I have a fraction that is over 3 and a fraction that is over 6? The lowest common multiple of 3 and 6 is 6, which means that this second fraction is not going to change because it's already over the common denominator. It's already over a 6. How about this one though? 2/3 to be over 6, the 3 has to be multiplied by 2 to give me a 6. So the 2 will also be multiplied by a 2 to give me 4/6. And remember, this number is not changing. I doubled the 3, I doubled the 2, but I don't have to double this, and I don't want to, because that would change my fraction into something else. If I doubled it, I'd have 4 4/6. That's way too big. That can't be equivalent to 2 2/3. 2 4/6, though, is equivalent to 2 2/3. And now we can go ahead and do our subtraction. 2 minus 1 is equal to 1. 4/6 minus 1/6 is equal to 3/6. And as you all know, 6ths is Doug's favorite denominator because he has to slow down so much whenever he says it. And then our final answer can be simplified a little bit more. It's already in a mixed number, and the numerator is not bigger than the denominator, but 3/6 can be reduced to 1/2. So my answer ends up being 1/2. How do I know it's 1/2? 3 and 6 have a greatest common factor of 3. I divide 3 by 3 and I get 1. I divide 6 by 3 and I get 2. 3/6 is equal to 1/2. That makes sense. We have done it. We have done a subtraction when the denominators were not common, at least not to start. Let's do another one. 3 5/8. 3 5/8. That's my first fraction. minus, let me get a little bit more chalk, minus 1/4. Oh, okay, here's a different one. It's not two mixed numbers. It's a mixed number, and I am subtracting a fraction that is not a mixed number. Does that stop me? No. I have to have the same procedure. The procedure is I cannot do this until I make sure that they have a common denominator. The lowest common denominator of 8 and 4 is going to be 8. The lowest common multiple of 8 and 4 is 8. So I will convert this. This one's already over 8. 3 and 5/8 doesn't have to change. But to get 1/4 to be over 8, 4 times 2 gives me the 8. 1 times 2 gives me a 2. Now we have a common denominator. Now, does this look a little confusing? I better slow down. 3 minus what? There is no whole number there. If I want, I can say 2/8 is equal to 0 and 2/8, but I don't know if that would make it look more confusing or less. I think maybe a little more. So I can just say 3 minus, and I don't have a number there, is going to give me 3 because I'm not subtracting anything from the 3. 5/8 minus 2/8 is 3/8. My answer is 3 and 3/8. Does it make sense? Yes, it does. So we can even do this when we have a mixture of mixed number and regular fraction. We're still able to do this. That's interesting. Now I want to do one. Let me see where I am here in my list. Yes, I am going to insert another example. There is a type of example I want to have which is not really here. So I'm going to insert one. I'm going to make one up. Let's make up a good example. How about 3 and 1/4? No, I'm going to do 3 and 3/4 minus 2 and 1/5. Because we had somewhere when we found the common denominator, it turned out that one of the fractions didn't have to be expanded. Because we had denominators where one of the denominators was a factor of the other. So you end up with the lowest common denominator, the lowest common multiple, being one of the denominators you started with. Well, that's not going to happen here. 4 is not a factor of 5, 5 is not a factor of 4. The lowest common denominator is not going to be 4 or 5. So we will proceed in the way that we would do even if they were not mixed numbers. I want to find the lowest common denominator when I have a 4 and a 5 as my denominators. And then what am I doing? Well, the shortcut is I multiply them. 4 times 5 is 20. That always will give us a common denominator, but it won't always give us the lowest common denominator. In this case, though, it will. If I list all of the multiples of 5 and all the multiples of 4, the smallest number that's on both lists is going to be 20. So I need 20 as my new denominator. The 3 is not going to change. Remember, when we modify these fractions, the big number, the whole number, doesn't change. The 2 is not going to change for the same reason. Now I'm expanding. I have to slow down because there's more steps to this one. We're expanding 3/4 so that it's a fraction over 20. How do I get 4 to turn into 20? I multiply it by 5. So therefore I would multiply the 3 by 5 and I get 15. Yes, 15/20 is equivalent to 3/4. I get 5 to turn into 20 by multiplying it by 4, so I have to multiply the 1 by 4 and I get 4/20. Now I can go ahead and answer my question. Whole numbers, 3 minus 2 is equal to 1, and then 15/20 minus 4/20 is equal to 11/20. I have my answer. It doesn't have to be simplified. That worked. The fact that 4 and 5 needed a common denominator and that it was quite so quick and easy as some of the other examples didn't matter because we know these techniques already. We're just applying them to a slightly new looking situation. Take a quick look at the time. Okay. Now all of these, when we did the subtraction part, the first fraction was bigger than the second one. But that doesn't always happen. You can't count on that always happening. So now we need an example where that doesn't happen so that we make sure we know how to deal with it. So that leads me to my next example. more chalk. How about 8 1/6 minus 5 5/6? There it is again, Doug's favorite denominator, sixths. Okay. They're already over common denominator, so that part's easy this time. I can go right ahead and subtract. 8 minus 5 is equal to 3, but wait, 1/6 minus 5/6. Whoa, that's not what I want to do. I need to modify for a different reason. I'm going to modify this first mixed number so that its fraction part is bigger than this one so that I can do my subtraction. So how do I do that? 8 1/6 is equal to 7 plus 1 1/6. So I'm borrowing 1 from the 8. And I'm just choosing to write it this way because it's easy to see what I'm doing. This part I'm not changing, not doing anything to this yet. Well, 7 plus 1 1/6, but I can convert 1 1/6 into an improper fraction. I know how to do this. How do I do this? I say 1 times 6 plus 1. Big number times bottom plus top gives me new top. So I'll write that down here. I'm still going to write the 7. 1 times 6 is equal to 6 plus 1 is 7. And the denominator stays the same. So 7 7/6 is equivalent to 8 1/6. And when you really think about it, it makes sense. If you tried to picture this as being a whole bunch of pizzas, well, there's 8 full pizzas and one pizza that is divided into 6 pieces, but there's only one left. Here's 7 full pizzas, and then you have 7 more slices. But these pizzas are divided into, well, that can only be if you had another pizza and then a pizza with only one slice left. It really means the same thing, whether you think of it as pizza or not. So I have converted 8 1/6 into 7 7/6, which I did with a purpose, because now I can do my subtraction. 7 minus 5 is equal to 2. 7/6 minus 5/6 is equal to 2/6. I have an answer. I was able to do it even though this fraction was smaller than that fraction, thanks to the mixed number helping me out by loaning me a whole whole number. Okay. And then, one last thing. My final answer isn't final because it's not as simplified as it can be. 2 over 6 can be reduced to 1 over 3. So therefore, I am dividing 2 and 6 by their greatest common factor, which is 2. And that gives me 1/3. 2 and 1/3 is my final answer. 8 1/6 minus 5 5/6 is equal to 2 1/3. It works. Okay, that was fun. Let's do another one that's kind of like that. Lots of addition and subtraction so far. We will get to the multiplication and division fairly soon, but I needed to do a lot of these with the addition and subtraction because really the process with multiplication and division, like so often happens in fractions, is sort of more straightforward. Multiplying and dividing is often easier than adding and subtracting. And we don't necessarily always expect that, but with fractions I have learned to expect it. So the subtraction and the addition have a few more steps, a few more challenges, and we have to slow down sometimes. How about 4 3/10 minus 1 1/2? Okay, we do not have a common denominator, not yet, so we have to do something. This time though, 2 is a factor of 10, so my greatest common denominator is going to be 10. The lowest common multiple of, I said greatest common denominator? My least common denominator is going to be 10. The lowest common multiple of 2 and 10 is 10. So what does that mean? It means that this one is not going to change. It's already over the common denominator. This one though, in order to get that 2 to turn into a 10, I multiplied it by 5, so the 1 has to be multiplied by 5, and we're not surprised to see that 1 1/2 is equal to 1 5/10. Now we have a common denominator, so we can subtract, right? Well, actually not quite yet, because 3/10 is smaller than 5/10. This thing happened again. So what I'm going to do is I'm going to convert 4 3/10 into 3 plus 1 3/10. I'm I'm borrowing one of these 4, so there's 3 left. But the one I borrowed is right here. This one I don't have to do any borrowing. Okay, 1 3/10 though, I want to express this as an improper fraction. I'll move over here. The 3 I'm still going to have. Then 1 3/10, converted into an improper fraction. Big number times bottom, 1 times 10 is equal to 10, plus top, 10 plus 3 is 13. Big times bottom plus top, 1 times 10 plus 3, 1 times 10 equals 10 plus 3 is equal to 13. 13, denominator stays the same. So no, we're not surprised to see that 1 3/10 is equal to 13/10. Okay, 3 13/10 now, we have to subtract from it 1 5/10. Is this all going to fit on my video rectangle? Yes, it is. Should I write the answer down here? Yes, I am sort of sprawling all over the wall here, but I will write the answer down here. My writing is always messy when I'm down at the lower part of the chalkboard wall, so please forgive me. 3 minus 1 is equal to 2. 13/10 minus 5/10 is equal to 8/10. I have my answer. It worked. The borrowing thing worked. But 2 8/10 can be simplified because 8 over 10, 8 and 10 have a common factor of 2. We can reduce this fraction. So therefore the 2 doesn't change. 8 divided by 2 is equal to 4. 10 divided by 2 is equal to 5. 2 4/5 is our final answer. That was actually quite a lot of fun. I think I should do another. Can I make that happen again? I was happy with the way this went. Yes, I know what I want to do. I have to think up a good example. So I'm adding another example to my lesson plan. What is Doug trying to make happen? Okay, let's see. I'm going to make sure that my whole numbers, that the first one's bigger. So I'm going to say 7. And then I am going to subtract something smaller than 7. So I'm going to put a 3. That's comfortably smaller than 7. This will work. And I need my fraction bars so that I can figure out what fractions to use. I don't want to use denominators where one of the denominators is a factor of the other. I want to make it a little more challenging than that. So I'm going to use 4 and 6. And what I do want to make happen is I want this fraction to be smaller than that one so that I have to do the borrowing thing. So I'm going to make it 1/4 and 5/6. Make sure that I'm not accidentally just recreating a question I've already done. But this one looks pleasingly different. Challenging? Yeah, but are we up for a challenge? Yes, we are. We're getting close to the end of the addition subtraction part of this lesson. And when you get close to the end, that's when you take on the challenges. That's when you say, okay, now I'm ready, I can handle everything. And you prove it by doing it. So let's see. First I need the common denominator. I'll go over here for now because I know this is going to take up some space. So the 7, the lowest common multiple of 4 and 6. Now, if we do that trick where we multiply 4 times 6, we get 24. And yes, 24 would be a common denominator, but it's not the least common denominator because 4 and 6 also have 12 as a common multiple. So 12 is what I'm looking for. Okay, so this one I've started constructing it over 12, but I'm going to write the rest of my problem, make sure I don't go right off of the video. There, I need my big 3. I'm going to make this one be over 12 as well, of course. Okay, I'm getting there. 1/4 to convert it to something over 12. 4 times 3 is equal to 12, so 1 times 3 is equal to 3. 7 is 3/12. Then, to get 6 to turn into a 12, I multiply it by 2. 5 times 2 is 10. Okay, I did it, but I can't do my subtraction right away because 3/12 is smaller than 10/12. We have that little challenge to deal with. So I am going to write equals, and I am not going to write 7 because I'm in a position where I have to do some borrowing. So instead of writing 7, I'm going to write 6 plus 1 and 3/12. Yes. So 7 and 3/12 can be written as 6 plus another 1, which just makes 7. 6 plus 1 and 3/12, it's the same total. And then I am subtracting 3 and 10/12, of course. Now, I don't want to write this as 1 and 3/12. I want to convert this into an improper fraction. So I'm doing that conversion. Big number times bottom plus top equals new top. 1 times 12 is equal to 12 plus 3 is equal to 15. Let me be careful where I write this. 1 times 12 is equal to 12 plus 3 is equal to 15. Denominator stays the same, it's still a 12. So 1 and 3/12 is 15/12, and I can just put the 6 right next to it. And now I'm just continuing my subtraction. Minus 3 and 10/12. This is going to work. 15/12 is bigger than 10/12. The borrowing worked, it's going to help. 6 minus 3 is equal to 3. 15/12 minus 10/12 is equal to 5/12. And this time the answer cannot be simplified any further, so that's my final answer, 3 and 5/12. 7 1/4 minus 3 and 5/6. Who would have thought we'd be able to do this? But by applying a couple of new techniques like this borrowing thing, by not being confused by all the extra numbers in the problem, by just slowing down and pacing ourselves and applying all of the techniques that we've been working on lately, we're still able to do it. It doesn't really get much more complicated than this, and we can handle it. That's good. And that is, did I do? Oh, there's an example I didn't do yet, which I don't think is as challenging as this one, but I'm going to do it anyway because I still have time. Okay. So 4 and 3/10. Wait, did I do this? I can't remember if I did it or not. So what should I do? If I decide to do it now because I think I didn't do it, then what if I already did it earlier in this lesson? I'll look silly. So what if I just make up another one? And again, I want to choose one where the common denominator is not going to be one of the denominators we already have. So let's construct another example. This is actually kind of fun to talk about how the teacher makes up a good example. And I know students are very good at making up good examples as well. Okay, let's see here. Another one that feels a little bit challenging. Thinking of common denominators. I guess I'll try 5 and 1/8 minus 4 and 2/3. I'm being very daring here because you notice how this number is almost as big as that number. But that's why I know this will work, that I'll be able to do this, because I can see by looking at the mixed number, because I have number sense, and I have number sense even with fractions, and even when they're mixed numbers, I can see 5 and 1/8 has to be bigger than 4 and 2/3, so this has to be doable. 5 and 1/8 pizza. This is obviously more pizza than 4 and 2/3 pizzas. Okay, so I have nothing to fear. What will I do? I need my denominator. I can do the shortcut 8 times 3 and get a denominator, and it will be a common denominator, but is the least? In this case, actually it will be. The lowest common multiple of 8 and 3 is 24, which is the same thing I get if I multiply them. But I don't like to just immediately multiply the denominators I have. I like having the least common denominator. In this case, though, it is going to be 24. So I'm converting 5 and 1/8 into 5 and something over 24. And I'm converting 4 and 2/3 into 4 and something over 24. Try not to do too much at once. How does 8 turn into 24? I multiply it by a 3. Therefore, I have to multiply this one by a 3. And I have 3 24ths there. How does 3 turn into a 24? I multiply it by 8. So I have to multiply this 2 by an 8, and I get 16. This does look quite challenging. 16 24ths is much bigger than 3 24ths. But I'm not going to worry. I've learned techniques that I know work for doing this, so I'm just going to go ahead and do them. in order to get this fraction bigger than that one, I'm going to have to borrow. So that 5 is turning into a 4, plus 1 and 3/24. Some people might want to skip this step, but I don't recommend it. I think I like having this step there because it makes me slow down, it makes me be careful. Then I'm going to subtract 4 and 16/24. Okay, but 4 plus 1 and 3/24, I don't want this to be in this form. I want to convert this into its own improper fraction. Same technique as always. 1 times 24 is equal to 24 plus 3 is equal to 27. Notice how I leave a bit of space. That becomes 27/24. And I have to put this 4 with it. Minus this one, 4 and 16/24. Okay, I can do this, but oh, something interesting happened. Told you it'd be interesting. 4 minus 4 is equal to 0. Well, I don't really want to write a 0. I guess I could write a 0, but I don't really want to. That's just, like, big numbers canceled each other. 4 minus 4, there's nothing. Okay, but I still have to do this part. 27/24 minus 16/24. 27 minus 16 is 11. I have my answer. That kind of took me by surprise. I have my answer, and it doesn't need to be simplified any further. Okay, so my answer ends up being a fraction that's smaller than 1. It's not a mixed number. Are we surprised? We shouldn't be too surprised, because we look at the original question. What we had is 5 plus just a little bit more than 5. 5 and an 8 is just a little bit more than 5. And 4 and 2/3. 4 and 2/3 is almost 5. So I took a number slightly larger than 5, and I subtracted a number that's slightly smaller than 5, and I ended up with an answer that doesn't need to be expressed as a mixed number. That's cool. I'm glad I made up that example. That was a fun example. Okay, I am finished with this page. I only have a few more left, but none of them are additions or subtractions. We are moving on to the multiplication and division. And it doesn't take us long to go over this, because the approach we make with multiplication and division isn't really the same or as long as the approach that we've been following with the subtraction and the addition. So let's get into a nice easy multiplication problem to start with. But first I will take a quick sip of my fizzy water. Oh, that is so refreshing. Just a hint of root beer flavor. It's not like drinking a can of root beer or even a can of diet root beer. It's just fizzy water with a little tiny little bit of hint of flavor. I like that. It's subtle. Like this question right here is subtle. 5/8 times 4. We've seen this before. When we first did multiplication of fractions, we did a bunch of multiplication of fraction times fraction, fraction times fraction. But then we said, hey, what if it's fraction times whole number? So this isn't actually new. What do? We turn this into a fraction by putting it over 1. You can turn any whole number into a fraction by putting it over a 1. 5 times 4 is equal to 20. 8 times 1 is equal to 8. There's not much left to do here, but there is still some left to do. We can both reduce this and convert it into a mixed number. So let's do the mixed number thing first. 8 fits into 22 times. 8 times 2 is 16, so there will be 4 left over. We have a remainder of 4. 20 minus 16 is 4. I have 2 4/8. But of course, 2 4/8 can be reduced. 4 and 8 have a common factor of 4. I will divide them by their common factor. 4 divided by 4 is 1. 8 divided by 4 is 2. We have 2.5. 2.5 is our answer. Okay, so that was sort of a review because we'd seen some before. We didn't start with mixed numbers. What do we do if we have mixed numbers? Well, it's not going to surprise you too much. Let's write down an example where we're multiplying fractions that are mixed numbers. Taking a quick look at my time. 3.5 times 4 1/3. Are we going to try multiplying the big numbers, the whole numbers? No. What we're going to do is we're going to convert both of these into improper fractions. 3 times 2 is equal to 6 plus 1 is equal to 7, 7 halves. And this is a review, so I admit I was going very quickly there. Big number times bottom plus top. 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Yes, I did it. I'm double checking by doing it more than once. Make sure I have it right. Big number times bottom plus top. 4 times 3 is 12 plus 1 is 13. So what we do when we have mixed numbers and we're multiplying is we convert them into improper fractions. And then we multiply like regular. One thing that's not like regular, I guess, is when you're doing this, you're always going to end up with big numerators compared to the denominators. It kind of stands to reason. When you convert a mixed number into an improper fraction, you end up with a larger numerator than the denominator. Okay, and how do we multiply? We do top times top equals new top, bottom times bottom equals new bottom. 2 times 3 is faster, so I'll do it first. 2 times 3 is 6. 7 times 13, hey, that's outside of the 12 times 12 multiplication tables. But does that bother us? No, it doesn't. We're supercharged. 7 times 12 is 84. So 7 times 13 is going to be 84 plus another 7. And 84 plus 7 is 91. I have my answer. But I started with mixed numbers. And I ended up with this very improper fraction. I think I should give my final answer in the form of a mixed number. It just seems like the polite thing to do. How many times does 6 fit into 91? 15. 6 times 15 is 90. So not the easiest one, but we have big numerators, so we're not too surprised to have a big numerator in our simplification. 6 times 15 is equal to 90. 91 minus 90 is 1. Denominator stays the same. We can do it. We can do it. And this is also a review. So when you're doing this multiplication, this is going to happen a lot. Well, every time, I think. Okay, so let's do a few more. How about, next example. Two and 4/5 times 3 and 1/3. Well, now that we know what to do, we realize, well, it's kind of all a review, because we know how to multiply fractions the way we just did, but we also know how to convert mixed numbers into improper fractions, and we have to do both. 2 times 5 is equal to 10 plus 4 is 14/5. It's good practice. 3 times 3 is equal to 9 plus 1 is 10/3. Now we can multiply. We don't need a common denominator. This is a multiplication. 14 times 10 is 140. That's not too scary. 5 times 3 is 15. Okay, but now we have to convert this into a mixed number. How many times does 15 fit into 140? And again, we can go and get a calculator if we need to, or we can start adding up a bunch of 15s. We can do a division like this. We can do one of those, but I like to do things in my head when I can, and I like to use tricks to do it. 15 times 10 would be 150. And 140 is almost as big as 150, so something tells me that 9 is the number I need. What would 9 times 15 be? 9 times 10 is 90, and 9 times 5 is 45, and 90 plus 45 is equal to 135. That's working. Okay, so that big number is a 9. 15 times 9 is equal to 135, and 140 minus 135 is 5. And the denominator stays the same. But hey, look, we have to reduce. 5/15 can be reduced to 1/3. So 9 1/3. Interesting. And then I remember, this is a review, because we've seen this situation before as well. We could have done some simplification here. We could have done some canceling. If we wanted to do it with canceling, 10 and 5 have a common factor of 5. If I divide out that 5, this turns into a 1, and this turns into a 2. And then I get 28/3. 14 times 2 is 28. 1 times 3 is 3. And then it's a little faster to convert it into the mixed number. 3 fits into 28, yes, 9 times, because 3 times 9 is 27. 28 minus 27 is 1. Denominator stays the same. Doing it both ways works as a verification, makes me feel confident in both of them. I like that. Okay, those were multiplication. Now I'm going to do a division. I have just enough time to do a couple of divisions. We all know also, though, that division is a lot like multiplication when you do fractions. With division, you turn the second fraction upside down and you multiply instead. And that's why people find division not to be too difficult to learn. But wait, what if it's mixed numbers? We have to find out by doing it. 4 and 5/8 divided by 2 1/4. What should I do first? I will convert them into improper fractions first. 4 times 8 is equal to 32 plus 5 is 37/8. I'm not turning the second one upside down yet. No. I still have to do some conversion. 2 times 4 is equal to 8 plus 1 is 9/4. Now I feel comfortable turning this upside down. So I keep 37/8. I multiply instead, and I turn 9/4 into 4/9. Can I simplify with canceling? Yes, I can, just a little bit. 8 and 4 have a common factor of 4. 8 divided by 4 is 2. 4 divided by 4 is 1. Oh, that's good, because I don't have to do 37 times 4, not anymore. I just have to do 37 times 1, and that's a fairly easy one. 2 times 9 is 18. Oh, and 18 times 2 is 36, which is almost 37. It kind of feels easier than you'd expect to convert this back into a mixed number. 18 fits into 37 twice, with 1 left over, same denominator. I have my answer. Oh, that wasn't so bad, was it? It's the same techniques that we've been already doing, and we're just putting them together in a little bit of a different way. And that's good news. One more. And I tried to make this a kind of a challenging one. I don't know what I was looking at over there. Just stopped. I was looking at this actually. Tried to make this one a bit of a challenger because it's the last one in my lesson plan. Last question will be another division. 3 4/5 divided by 2 3/4. Doesn't look especially challenging. It doesn't look really much more difficult than the other ones we had been working with. But first we have to convert into improper fractions. 3 times 5 is 15 plus 4 is 19/5, same denominator. Don't try and turn this into a multiplication yet. 2 times 4 is 8 plus 3 is 11/4 or 11/4. Now I can turn it into a multiplication, but I have to turn the second one upside down. 19/5 times 4/11. I'm being careful not to copy it down incorrectly. Can I cancel anything? No. 19 and 11 and 5 are all prime. I can't cancel anything. And that's why it feels a little bit challenging. 19 times 4. 19 times 2 is 38. And 38 times 2 is 76. Therefore, 19 times 4 is 76. Okay, not so bad. 5 times 11, that's an easy one, 55. It's not so bad. It's just the final answer might not look as clean as some of the others because 55 fits into 76 only one time. And 76 minus 55 is 21. So 1 and 21/55 ends up being our final answer. And that was my final example. What am I doing for time? Quite well, actually. So that was fun. It is the last in this series of lessons about fractions. We're going to move on to some other things like decimals, and eventually we will work on percents. And I just want to give you a little bit of a warning, but it's a good warning. It's good news. We will need this again. All of the stuff we've been learning with fractions, we will use again in the future because it comes back. When you start working with other forms of the numbers, the decimals, and especially the percents, fractions are involved. But that's good news. It makes it fun. you know 3 different types of number, and you can go back and forth between them. You can do operations where you have a mixture of these numbers. This is where we're headed. For now though, I am just headed upstairs to have supper. And I want to say goodbye from me, from my beautiful assistant Mocha, who is upstairs, from my Liverpool jersey, and from my dreary cold October weather. So me and my slippers will see you next time. Goodbye.